What's good, everybody? I'm Clarence Stephen. I run Clarence Stephen Solutions, AcceLLM, and Readify. Feel free to ask me about it in comments, and I'll go into more detail. On this video, because I teach data science, I want to have a take and share with you on what's going on LinkedIn, and my response might make some people uncomfortable. So there's this post going around right now. It's an interview question for, quote, ML generalists. And the question is basically, let me have my intro here. Here's some math. Okay. What is it? What can you build with it? Well, what is it? Okay. Well, it said ML generalists. So I'm going to assume these arrows represent encoders. And this little Z hat represents the predictor. And this min E is minimizing the loss function. So that's all basic machine learning notation. In fact, I think the notation is a little bit misleading because this is all pretty basic when you get down to it. Now, the interview question is, tell me what product you'd build with these equations. Cool question, right? Very clever, tricky. The original poster even said the new grad who answered it got a strong hire. Let's see what I said. I said, unsubscribe, not a fit. Someone asked me this question during an interview, huge red flag. Is this the type of team I want to work with? Why are we starting with the model equation and then figuring out what problems it solves? That's backwards. Imagine I gave you Pythagorean theorem, a squared plus b squared plus equals c squared, and then said, now go build something with it. You'd be like, well, what? What's A? What's B? What's C? What are we trying to do here? What's our job? What company do we work for? How is this going to help me build a new iPhone 20? So look, I'm going to play along. I'm going to break the math down. We also got a response, by the way, which was pretty nice. And look, we know this is a latent space dynamics model. If you don't know that, you can copy and paste it into Google or your favorite LLM. So when you look at the actual function, the arrows represent encoders, right? The hat above the Z tells us that we're predicting the next state in this compressed space. And this E, your error function, is being minimized, which is what the min says. Well, that's very basic. I bet you can get a high schooler to guess that if they have a little bit of statistics. Now, if you've read Leakel's JEPA or JEPA papers, you recognize the skeleton immediately and you know the answer and you know what it's for, and you can stop watching this video and go do something else with your time. So this is anomaly detection on sequential data. You leave it on, you train it on normal data, like it keeps going and going, it keeps producing ZT plus 1, and then you observe your ZT plus 1, and you compare the predicted ZT plus 1 to the actual one. No surprises, keep going, leave it running. Something big happens, time to take a look at what's wrong with your model or your machine or whatever's running the system. So you train on normal data, flags and surprises, done. 3 sentences. That's it. That's the math. Let me say that again. It's anomaly detection. Train on normal data. It flags surprises. Done. That's it. Okay? Boom, boom. But here's what I actually commented on that post. Unsubscribe. Not really, but kinda. If someone asks me this question during an interview, it's a red flag. Not because the math is wrong, not because it's a bad question. It's just a red flag for me because of what the question reveals about how that team thinks and approaches problem solving. They're starting with equations and math and working backwards to find a solution to a problem. That to me makes no sense at all. So I don't start with an equation like Pythagorean theorem, a squared plus b squared equals c squared, and then say, what can I build with this equation? That's just not the way it works. Let me tell you how this actually works in the real world. I mean, nobody's walking around the trading floor or walking into a boardroom and saying, hey, guys, let's look at this latent space equation and see how it works in the real world. I've got my loss function. What can we sell with this loss function? That's just not how it goes. That's not how products get built. That's not how conversations go in the office. It's just not realistic. Might be how your interview goes. For me, that's great. I know to walk away. That's not the team I want to work for. But if this jives with you, then you want to look for teams that ask these kind of questions, especially if you have a PhD. So me, on the other hand, I run businesses. I like to make money, and mathematics helps make money, but in itself, it does not make money. Otherwise, we'd all be rich after graduating from college. So that's not how any of this works. You start with a problem. You start with a pain point. You start with someone losing money, wasting time, making bad decisions, or an app that doesn't work, or something that's broken. And then you come up with a KPI, or you quantify it. And then, and only then, do you figure out the simplest technical approach that solves it to understand it. That's Occam's razor. Keep it simple, stupid, right? So half the time, the solution isn't deep learning. It's more likely a simple model that lets you understand the important features. And then if you have time, you dive into an XGBoost. And then if you really have time, you can get fancy. Tap your PhDs, get them involved, make them make something cool that nobody understands except them, but it spits out good metrics. I mean, that works for some businesses. That's not how I would run a business. I like things practical, explainable, and I like real results that are measurable, like cash. So you're building a rules engine at the end of the day. So it's a SQL query and a dashboard. Someone looks at it on Monday morning and they know what's going on. That's your goal. So not sitting down, going down through math equation ever. So I call this cash over math, capital C, capital M. Cash beats math every time in business, not at a math competition. If it's alpha theta, math beats cash. So let me give you an example. Say you've got a hospital system, 30-day readmission. Rate is 14%. So every unplanned readmission costs the hospital somewhere between $15,000 and $25,000. Multiply that out, you're quickly looking at millions in avoidable costs per year. That's a problem. Plus penalties on top of that. Now, do you need latent space dynamics model to solve this problem? Do you need joint embedding predictive architecture? No. You need to understand the problem. You need to understand the data. And you probably need a logistic regression on discharge summaries, medication adherence, and social determinants. What does that mean? You need a little bit of math and a lot of real world knowledge. Maybe you graduate to a gradient boosted model if the signal is there. And maybe you eventually get to something more sophisticated. But when you're losing millions of dollars, you need to earn your way to complexity. You don't start there. You got to start solving the problem as quickly as you can. And that starts with understanding it and then building a basic model. So the interview question I'd rather hear is this. Here's a business losing $2 million a year to unplanned equipment downtime. What do? Oh, I built this. That's the correct answer. That's the correct direction for me. Here's the problem, or imagine this problem, or your system breaks one morning, or you get a bad signal, or your KPIs are off, or a graph looks off. That's how things start. That's how bad days start. And you hope they end well. So you see how different that feels? Now we're talking about sticks. We're talking about ROIs. We're talking about what actually matters, not math equations. Not that I'm against that. And you know what? Maybe the answer does involve a latent dynamics model. Maybe it involves the exact same math from this LinkedIn post. But you arrive at that because you understand the problem, and the problem demands that solution. Not because you took an equation that you really liked and then went and found a problem to fit it with. That's just not how it works. It's the wrong direction. So now I want to be clear about something. Because people hear cash over math and they think I'm anti-math. I'm not. I love math. I studied physics at Yale. I was a alpha theta champion. Got a bunch of national trophies for geometry, proportions of variations. statistics, and what was the other one? Trigonometry. Yeah, that's right. I was a top national ranked mathematics from high school, which was over 20 years ago. So nobody really cares. I read white papers. I generally enjoy understanding how attention mechanisms work, loss functions, optimization, landscapes, why certain architectures converge and others don't. I like reading about embeddings. I think I have a better understanding than the average person. I think the embedding layers are one of the most important layers of LLM systems. I just recently read about Transformers XL. It's pretty interesting. I recommend reading it if you haven't. And it's that curiosity that makes me better at my job. When something breaks or underperforms, I know where to look and I know where to start. When a client asks, why is this doing something weird? I don't grab a math book. I can actually explain it, not just restart the notebook and hope that it works. Here's the distinction. I keep the math in my back pocket, not on my business card. Clients don't want to see it. They don't want to hear me say, join embedding predictive architecture. They don't want to hear me say, oh, well, this is gradient explosion. They need me to say, here's what's breaking. Here's what it's costing you. Here's how we can fix it fast. We'll come up with a long-term solution after we fix the immediate problem, right? So understanding the theory is quite an advantage. In fact, I always dreamed that my perfect job is I have the domain knowledge, let's say equity derivative trading, and the guy sitting next to me has a PhD in equity derivative modeling. Boom, we're the dream team. Carl Malone and John Stockton. So solving the business problem is a job. And by the way, that LinkedIn thread was actually really interesting. You can go through it. It goes on and on. You had researchers giving textbook JPA answers, engineers pushing back on the format, people proposing things from stock predictors to habit tracking apps, the debate on health. I think the commenters who pushed back, like me, said, why are you asking this in an interview? See, we're onto something. Because the question you ask in an interview tells the candidate what kind of team you are. And if your opening move is, here's an equation, reverse engineer a product, you're telling them that you value mathematical performance, theoretical over practical judgment. That's math over cash. That doesn't work for a successful business unless your business is the math itself, like an educational institution. So that might be what you want. Maybe you're in the research group or research labs. But if you're building products, you're shipping features, you're delivering to customers, you're trying to drive positive experiences and raise revenue, you need people who know how to solve problems, not make problems out of equations. So that's my take. Cash over math. So Clarence Stephen, reach out to me if you need to talk about your career. I do consulting in that space. Reach out to me if you got a big project you want to build. We'll get AcceLLM on it. And soon we'll be talking about Readify, which I think everybody will find fun to play with. Drop a comment. Tell me if I'm wrong. Tell me what I said that was dumb. Or tell me you've been thinking the same thing. Let's go. Thanks for listening.